Welcome to The Explainer. Today, we're diving into an idea that sounds like it's straight out of science fiction, but it's happening right now. We're talking about a framework that could fundamentally change how artificial intelligence learns, grows, and, well, evolves. So let's just start with that massive question right there. What if an AI could do more than just get better at a task? What if it could literally reach into its own programming and redesign its own mind to become a smarter, faster, more efficient learner? Now, to really get why this idea of a self-upgrading brain is such a revolution, we first have to talk about a core problem, a fundamental limit that most AI systems have today, and it all comes down to their memory. Think about it this way. For most AIs, memory works like a big, static file cabinet. It's great at storing stuff and pulling it out when you ask, but the cabinet itself never changes. It can't reorganize its own drawers or figure out a better filing system. The leap we're talking about here is going from that passive cabinet to a truly dynamic, evolving brain. It's a concept called architectural intelligence, where the AI doesn't just use its brain, it actively improves it. And this is exactly where the MemEvolve framework enters the picture. It's all about creating this massive shift, a shift in what it even means for an AI to learn something. You see, MemEvolve wants to turn AIs from what we'd call skillful learners into true adaptive learners. A skillful learner is like a chess program. It's amazing at chess, but that's all it knows. An adaptive learner, on the other hand, masters the art of learning itself. It can actually change its own internal structure to take on totally new and different challenges. This is a huge, huge step towards a kind of AI metacognition. Okay, so that's the what. Now for the really cool part, the how. How in the world does an AI actually learn how to learn? How does this self-rewiring process even work? Well, the system treats the AI's memory like it has a genetic code or a genotype. This blueprint has 4 core parts that can be changed and evolved. You've got your basics: encode, store, and retrieve. But the real secret sauce, the absolute game changer, is that 4th part: manage. This acts like a super intelligent librarian for the AI's brain, constantly organizing, summarizing, and even deciding what memories to forget to keep the whole system sharp and efficient. So how does this evolution actually happen? It's a really clever 2-step dance. First, you have the inner loop. This is like a student just doing their homework, trial and error, learning from their mistakes on a specific task. But then the outer loop kicks in. This is like the student stepping back after the exam, looking at their grade and saying, you know what, my whole study method is wrong. And then they redesign their entire approach for the next time. It's not just learning the facts, it's learning how to learn. And this is what makes MemEvolve so different from older methods. Traditional genetic algorithms were basically random trial and error, like throwing spaghetti at a wall and seeing what sticks. MemEvolve, though, is much more like an engineer. It diagnoses a specific problem and then designs a specific solution. And it's not just chasing one single goal. It uses something called Pareto ranking to find that perfect sweet spot between performing well, being cost-effective, and being fast. And this quote from the researchers just sums it up perfectly. This is not blind, natural selection like in the wild. It's an intelligent engineer with a lab journal, carefully diagnosing every failure and then methodically redesigning the brain structure to make it better. So all this precise engineering leads to one of MemEvolve's most startling and honestly game-changing capabilities. Get ready for this because it is a wild concept. The memory architectures that MemEvolve creates are pluggable. That means you can literally take the evolved brain from one AI and transplant it into a completely different one. It's like giving an AI an instant brain transplant, and with it, an instant upgrade. And this isn't just some cool theory on a whiteboard. It has a huge, measurable impact. In one test, they took a memory architecture evolved on one model, popped it into another one, and the result? A staggering 17.06% boost in performance. In the world of AI, that is a massive leap. And as you can see here, that 17% boost, that wasn't a fluke, not even close. They successfully transplanted an architecture into completely different models, like Kimi K2 and DeepSeek, showing it works across different platforms. They even integrated it into complex systems with multiple AIs working together. This incredible versatility is what makes MemEvolve so powerful. So, where does all this lead? I mean, if AIs can already evolve their own brains like this, What in the world is next? Let's take a look at where this is all heading. Believe it or not, the future is already starting to take shape. The most advanced systems are already evolving beyond simple straight line pipelines. They're developing these incredibly complex, interconnected, graph-based memory structures that, well, they're starting to look eerily similar to the neural networks inside our own heads. Right now, the evolution process is very deliberate. It's that diagnose and design engineer, carefully fixing problems. But the future might be a bit more, well, chaotic. The next step could be to introduce a bit of randomness, a bit of high entropy exploration into the process. This could be the key to helping an AI have a truly novel idea, the difference between making a car engine a little more efficient and suddenly inventing a warp drive. And that leaves us with this final, really powerful thought to chew on. If an AI can truly master the art of learning itself, if it can constantly and intelligently upgrade its own mind, then where does it stop? What are the limits to its growth? That's a question we're all going to have to start thinking about as this technology continues to evolve.